This is Algebra 2 with Trig, Unit 1B.4. We are going to be interpreting graphs, and we'll be using our graphing calculator. So what we're going to start with, this water balloon, always reminds me of Kelvin and Hobbes, is hitting y equals on your calculator, and we're going to type in our equation. Now this equation is actually in standard form, it's just not in the correct order of standard form. But the way that they have it written here is 128 plus 64t. Now we can't type the variable t in this mode, but it's still our input variable, which the calculator uses x for an input variable, minus 16t squared. So the negative 16t squared would be known as your a value, the negative 16. So that's telling you that this should be a parabola because the variable is squared. Negative is going to be the parabola is upside down. And 16 would imply that it was narrower than normal. But that can be affected by the way you make your window look. So the first thing we're going to do is look at our table. We're going to take this equation that we typed in and fill out our table. So we're going to hit second on the calculator and graph. So above the graph word is the word table. It's written in blue. So second table is how you get to table. And you can see, you can scroll up and you can see what happens when x is negative. We don't really care about negative time. You just scroll down. You can go as far as you want to. It's all the values that type in. So what we're looking for is where x is 0, which is 128. This is x, this is y, this is your time, and this is the height of the water balloon. So at 1 second, the water balloon goes up higher. At 2 seconds, it still climbs up higher. But then the water balloon starts to fall. And it starts to fall back down to 176, and then 128, of course 48, and negative 64. So that all came from the table. You could have figured out those values by plugging them into the equation, all individually. But we're using our graphing calculator. Why does the table stop after 6 seconds? Well, when we look up here at our calculator, at the table from the calculator, we see that at 6 seconds we get into the negative zone. Right? Y's are negative. We're not too interested where the height of the balloon is below the ground. We're not interested in data below ground level. So using the context of this problem, we're using the 0 of x to represent the beginning of the time from before we tossed the water balloon out, and the y values being the height. So we want to know when it's going to be hitting the ground. We're not too worried about when it goes mathematically below the ground. Okay, when we look at our window, window's a big deal because if we hit graph right now, you'll see a part of the graph go by, but we can't see the entire graph. It gets a little confusing. What's just happening with this? So we're going to start at trying to recognize what is the normal window, a zoom 6. there's a zoom button on your calculator, and if you hit that zoom button, there's many different zoom options. The one that we would use the most will be number 6, but that's not going to change anything that we currently have. Zoom 6 should take it back to the standard scale of 10 to the left, 10 to the right, 10 up, 10 down. So you can see the same thing that we had before. When we go to window, you'll notice that the minimum X value is 10 to the left, 10 to the right, 10 down, and 10 up. By looking at our table, we know that we're not interested too much about time being smaller than 0 seconds. Some people like to put -1 just so they can see that line of 0, no big deal. And our maximum time, we could use 10, but there's not much need to be 6 or bigger, right? Because we're still underground. So 6 would be fun to change it up. The scale, we'll talk about scale when we go back to the graph and can see just how it's done. The minimum, well, we might need to make some adjustments because we don't really know what the result is going to be, but typically people think that they want to have 0 be the ground because I don't need to see into the negative zone. So 0. And my maximum height. What's our maximum height for this problem? 192. So 192 is the maximum height, and if you hit graph, you can start to see what's happening here. We've cut off the second quadrant, that's way over here. We don't care too much about negative time. We've cut off the fourth quadrant because we don't care about negative depth. We just want to go to the ground. And we take our vertex right up to the very edge. We're using as much of our screen as we can. That's great. There may be situations where we have to make some adjustments so we can really see everything we want to see. What was our current window when we first began? Our current window was -10 for the minimum x, 10 for the maximum x, and the scale was 1. I didn't change the scale at all. Look here, and you'll still see 1 tick mark for every second that the water balloon is up in the air. The minimum y was also -10. The max was 10. And oddly enough, the scale was 1. Well, it makes sense when they're not so stretched out, but here we're going all the way up to 192, up to the very height. You can see that this pretty much looks like a solid line. It doesn't have any dash marks to show you as we're counting. So maybe you would want to come in here, and sometimes it's a trial and error situation, but maybe tens. If we counted by tens, could we see a little bit better where those tens were? Now you can kind of see where the tens are. It does not change any answers. It only makes the graph show the tick marks along the scale. Then here in the new window, we made some adjustments so we could actually see what was going on. We had a minimum of 0. We chose to use a maximum of 6 and a scale of 1. Wasn't much of a need to change that scale. The minimum value. We currently have 0 down and 192 as a maximum height. But most likely we'll be pushing that 192 up a little bit more so we can see a little bit better just where that top is. And the scale, we changed that to 10 so we could get some sort of a reading about how often 10 is happening along the side. So if you notice, each tick mark is really close to each other, and that's 10, but each tick mark is only 1 along the x. So this is not a square proportional. So it's difficult to tell that this graph is actually opening up much narrower than usual. because it's not proportionally drawn. What height is the dorm room window? What height is the spot where the water balloon goes out the dorm room window? 128. And those would be feet. We know that because at 0 seconds, that's where the water balloon is at. By looking at your table, you can see at 0 seconds, we're at 128. The graph had that constant number, what we would call C. It's not quite in the order we're used to it being, but it's the constant number. That would be the C value, and that's 128. Different ways for us to evaluate that answer. How do we know this? When time is x equals 0, the balloon is y equals 128. So the water balloon has not been tossed yet at the height of the window, and that's when we have noticed it's at 128. Now we can use a set of directions to help us know how to use our menus. There's some YouTube videos in here if that would be helpful for you, or you can follow along with what we're doing also. Yes? So looking here at our graph, we're going to use this calc button quite a bit. This calc button is right above trace. Look what happens when we hit trace. If you hit trace and you try to get to the very top, you got a few things that are getting in the way. One thing, you can't see the very top. Not anymore. So what could we do to make an adjustment to that?
Change our window?
We're going to change our window. If we change our window and make it go up kind of considerably more, even if we go all the way up to 225, you can see that that did not drastically move that down. And when we hit trace, we can now see, and we don't have that equation getting in the way. We don't know which one of these, if any of these spots, is in fact. Oh, isn't it 192? Is that the maximum height? And I can't really get this to hit 192. Well, that was pretty close, but it's not exactly 192. So that's the trouble with trace. Trace will never give you the exact answer. Okay? Interesting. All right.
I think it's because they're newer calculators.
So we're going to go to second trace, and we'll go to maximum. So we're looking for the maximum value, and it asks you a question down here on the left-hand side. First of all, you need to know where the maximum could possibly be, right? And it's asking you to be the left bound. So we have to go to the left side of where you think the vertex is going to be. So kind of thinking about a line of symmetry. I know my vertex is on that line of symmetry. My maximum point is on that line of symmetry. So I have to get to the left side of that. And I hit enter. Then what does it say? Right bound. So I have to arrow to the right side of my line of symmetry, to the right side of my vertex, to my maximum point, anywhere to the right, and I can hit enter again. Now it says the word guess. Well, sometimes guess is a big deal, sometimes guess is really irrelevant. If there is more than one arrow, more than one answer inside of the arrows, then it's a big deal. But here we have narrowed our window down, and there is only one maximum height inside of those arrow markers. So you could just hit enter right now. Or you can arrow over with your cursor to get closer to the real answer. You can get as close as you want to it and hit enter. Some of us might have an answer a teeny bit different to this. Now, first of all, it's good to realize, what did we just calculate? We calculated the maximum value. I suspect we all have the exact value of 192. All right, so that is our answer, 192 feet. Everyone has that. But where it becomes a little bit variable here is with F. When does the balloon reach maximum height?
At 2 seconds.
At 2 seconds. Now this implies maybe that it's not exactly 2 seconds. This makes it kind of seem like, well, it's almost 2 seconds. It might be a teeny bit over 2 seconds. That's not true. We can prove mathematically this is exactly 2 seconds. All right, it's just the result that's coming from the calculator. It's possible that your calculator would have shown you 1.99999. Anybody get that result? A couple of you got 1.9999. And if you get all those nines listed in a row, that is actually the same value as 2. Remember what you were calculating using this button. You were calculating maximum height. So it gave you the exact answer for a maximum height. It did whatever it needed to do for the x value. So understand that it's not rounding answers. It's giving you pretty accurate, at least decimal answers. But that's my explanation on why x is 2.000001. Some of your calculators may have shown you exactly 2. And that's possible. So x equals 2 seconds. What is the height of the water balloon when it hits the ground? Well, nothing is showing at the moment that calculation. It's just, what do we believe to be happening at that moment? What does it mean to have a height of hitting the ground? What's the height when we splat the water balloon on the ground? That would be a height, y, equals 0 feet. If the maximum height is 192, then the ground height is going to be 0. That makes sense. So now it asks us, when does it hit the ground? That's the big question. Now we need a graphing calculator to solve that one. There's a video here. It'll kind of walk you through a very similar process of what we're doing. Works out really well. All right, I want to show you something besides that left-bound, right-bound values. What we're going to do here is try to find what x value crossed out here when it hit the ground. So we'll go to second calc. Which term in here do you feel would represent hitting the ground? Minimum. Minimum would be a low point, right? But this is a calculator. It doesn't know about the storyline of a balloon and hitting the ground and friction and explosions and things like that. So when you look at the table, the water balloon goes to negative and goes on forever. You would never get a minimum in this situation. Good idea, but it does go on farther. 0. We're looking for the 0 of the function. So that's the one that we'll be going with. Other common answers, people talk about intersect, but intersect is going to be two functions. Where do two functions cross? This is going to be the 0 of the function, so we hit that. Look at what it asks for again. It asks for left bound. It wants to be on the left-hand side of the answer. Well, looking at your table, what number do we know is to the left of our answer in terms of time when it hits the ground? 0 is definitely to the left. Anything else looking at your table when we wrote it down on the other page? What was to the left of our 0 when we wrote this down here? Was 5 seconds to the left of the 0? Yeah, the 5 seconds, it was up at 48. At 6 seconds, it was past 0. So our answer is somewhere between 5 and 6. So instead of doing left bound and arrowing to the left of it, it is okay just to type in the number 5. It's a quick way to get there. If you know 5 is to the left of it, you can just type that right in. What number is to the right of it? 6 is clearly to the right of it. We saw that in our table. So we could very quickly type in 6, or you could arrow over, whichever you like, and you can hit that in. Now, the one trouble that we have here is we can't see down there. We can't see what's happening when x is 6. It seems like it's way off to the side, way down low. So we could change our window so we could see that a little bit better. That would work. Guess, is there more than one answer between 5 and 6? Or is there only one answer where x is 0? Or y is 0. Is there only one x where y is 0? Only one answer. So we could just hit enter, and there's your exact value. So you could use the arrow buttons to do left bound, right bound, or you could type in numbers to do left bound, right bound. Your choice. Whatever you're familiar with. If you know the numbers, you can type them in like we knew it from the table. That could work out well. So when does it happen? When x is 5.46 seconds. That's an approximated answer, but that's a pretty good approximated answer. Here it talks about you may want to change your window so that you can see more of your information and your axes aren't in the way. So you might want to change that y minimum to -20 so you can see a little bit better what's happening underground. So when you do that second 0 and you do the 5 and the 6, you can still see more of the x-axis, even though that may not even been high enough. It doesn't change the answer. Okay, we got our answer, 5.46 seconds. So we're going to look down here, and we're going to use this intersection option. So what we're going to look for is when will the water balloon be at 150 feet? Okay, some people think that you can look at your table to determine 150 feet. At your table, 150 feet would fall in between here. In between 128 and 176 is 150. So it must hit 150 in less than 1 second. And it hits 150 just over 3 seconds. So those are your two approximated answers, but we want better than that. So what we're going to do is go to y equals. We're going to type in the number 150. So when we graph this, we can actually see the line that represents 150 for whatever you want the storyline to be. A bird flies over and hits the water balloon at 150 feet height. At what time did that occur? Well, let's go find that location. We do second calc. We're going to find the intersection of these two equations now. So number 5. And again, it asks me for the first curve. This is different language. We haven't done this yet. First curve. They're not talking about because you have a curve. It's just the simple language. It should be equation. What is your first equation? Is this an equation you're interested in? Answer is yes. I typed it in. That's the one we want. And then is this your second curve? Well, of course it is. There's only 2 on the screen. That is true. Remember, your calculator can hold up to 10 equations on the screen. So it doesn't know what situation you're involved in. You might have multiple equations shooting through here. So it has to ask you, is this the equation you want to use? Is this the equation you want to use? And we hit enter for yes. And then it says guess. Well, is guess necessary? Wait a minute. These 2 graphs cross at 2 different spots. So guess is very important. Guess is going to give you an answer that the cursor is closest to. So if you want this answer over here, you've got a cursor over to it. Or if you want the answer closer to the right, you need to be sure that your cursor is closer to the right than it is to the left. And when you hit enter, you get your value that is at exactly 150 feet high. So we got x equals 3.62 seconds. Now, I typically like to move my cursor off to the side a little bit. We will do second calc again. We'll go to intersect. It asks us for the first curve and the second curve. Now it's very important for me to scroll all the way to the other side to get closer to the other intersection. So when I tell it to guess there, I actually get that answer. Otherwise, you'll keep getting the same result every time. So we get 0.38. We would round that up, 0.38. 0.38 seconds. So now we've seen where the water balloon is going to be at a certain height. What time does it hit there? What time does it hit the ground? What time does it hit the maximum height? What is the maximum height? All those parts that can be found using different menus of your graphing calculator. So you could have a test using your graphing calculator, and you'll have a portion of your test that has no graphing calculator allowed. So you need to know how to use it, and you need to know the other methods when we don't use it, which has been everything up to this point. Next, we're going to come to a little bit different topic and talk about revenue. Revenue has to do with the price of an object times the number of items. All right. Number of items that we're selling. So what we're going to look here is a video store is selling 150 DVDs a week at a price of $20 each. So that's our price, $20, selling 150 items. We want to get maximum value. Our revenue is going to be the price, which is $20. The number of items is 150. So in that situation, we're going to have a $3,000 profit. That's pretty good. But I'm greedy. I want more. The video store sells it for those prices. The owner estimates that each $1 decrease in price, if you make it cheaper, more people are going to buy it. Okay. About 25 more DVDs will sell. So our revenue is going to be a cheaper price. So what I'm going to show you is $20 minus 1. $20 minus 1 is going to be multiplied to 150 plus 25. Because we're adding 25 to the 150. So when we come to our calculator, we think about that as 19 times 175. We get 3,325. So we made more money. Our revenue is going to be the price. Now we're going to take $2 off the original price. That means we're going to go up by another $25, right? By a total of $50. So that's going to be our 18 times 200, and we get $3,600. So we're making considerably more money. We could continue that pattern. We could finally reach the answer. But a way that we can do this in 11th grade math is to say $20 minus 1x, because you're dropping $1 each time you do this. You're also going to sell 150 DVDs plus 25 extra ones for every dollar you drop, for every X that occurs. We can now bring that into our calculator and say 20 minus X and 150 plus 25X. And we can go to our table. And in our table, we can notice that we get a maximum height right here at 4,225. When x equals 7, our y value is $4,225. We used our calculator to help calculate that out. We could do it mathematically. We could use those. We could find our zeros of the function. This could be done by hand. But at the moment, we're looking at this one using our calculator. In our table, we could tell that that was the actual maximum because we had the same value on either side. So to figure out your price that you should sell things at, remember your price was 20 minus 7. So you should sell your DVDs at $13 a piece. And the number of items is going to be 150 plus 7 times 25. So with your calculator, 150 plus 25 times 7 is going to give you 325. So your 325 times your 13 should give you this maximum value that we're sitting at 4,225. That maximizes your profit. So you pause the video, you go ahead and try this one out and see how it comes out for you. And then run it again and we'll work it through together. We have a canoe rental business on the Ohio River. You currently charge $12 a canoe and you average about 36 rentals. The industry journal says that for every 50 cents increase in price, the average business can expect to lose 2 rentals a day. Use this information to maximize your profit. Well, remember, revenue is supposed to be price times the number of items we can sell. So our price is currently $12 a canoe, and we're going to have 36 rentals. That's going to be 12 times 36. That's going to be $432. Now, when we increase the price by 50 cents, all right, increase the price by 50 cents, we're going to lose 2 rentals. We're now going to have 34 instead of 36. Not what I expected. What this is indicating is that at our $12 price, we were making a higher profit than we would if we charged extra 50 cents increase in the rental price, would make us lose 2 people. So what I'm seeing, we have our 12, and we're going to add 50 cents X. We're going to have 36 rentals, but we're losing 2 rentals every time. So if we go to our calculator and we do our 12 and we increase the price by 50 cents, we are going to lose 2 canoes each time. You can see that we are actually decreasing in price for every time we were doing that. Decreasing all the way. So there is no, this isn't a great example. When we graph this one out, let's take a look at the graph. Let's take a look at, we should have a maximum value around 450. All right, we have an X value, of course, we'll say -10, and we'll go out to 10. We'll see what happens in that case. All right, you can see in this case that the highest point, the maximum value, is in the negative zone. So typically these problems would give you a maximum value on the right hand side. So to answer this question, this was our maximum value. There wasn't much to calculate. Not a great example in my mind. So what should you charge? We had maximum profit at $12 per canoe. Besides the graphing calculator, what other ways could we attack these problems to find the best plan for the maximum value? Where was the maximum value? Maximum value was at the vertex. So we would need to find the vertex. And you find the vertex by find the AOS, line of symmetry, axis of symmetry. Then plug in value to the our original equation to find max profit. The line of symmetry would give you the x value that you would need to do, and the y value would give you the maximum profit.